What if the greatest achievement of your entire life instantly triggered the beginning of your death sentence beneath the waves? Imagine being born as one of the ocean's smartest creatures, yet carrying a biological countdown that can never be stopped. From your very first moments, predators circle nearby, waiting for a single mistake that could end everything forever. Somehow, against impossible odds, you survive long enough to become a master of camouflage, hunting, and escape. You possess 3 hearts, blue blood, and a remarkable brain capable of solving problems that surprise scientists. But none of those extraordinary gifts can protect you from the strange fate written deep inside your body. For a male octopus, the final goal of life is not wealth, power, territory, or even long-term survival. Instead, everything leads toward one brief encounter that changes your body in ways that sound almost unbelievable. The moment you successfully pass on your genes, an invisible process begins slowly tearing your life apart. Why would evolution create such an intelligent animal only to make love the very thing that destroys it? Long before a male octopus faces the mysterious fate waiting at the end of his life, he begins as a tiny drifting larva in the open ocean. Unlike many animals that receive protection from parents, young octopuses enter the world completely alone from their very first day. Thousands of siblings may hatch at the same time, yet most will never survive long enough to reach adulthood. Ocean currents carry these fragile creatures across vast waters where danger hides behind nearly every movement and shadow. Hungry fish, seabirds, and countless marine predators view them as easy meals rather than future masters of camouflage. During these early stages, survival depends less on strength and more on luck, timing, and constant avoidance of danger. Every passing day becomes a silent test that eliminates countless young octopuses before they can fully develop. Those that survive gradually leave behind their drifting existence and begin exploring life closer to the ocean floor. Here, the challenges change, but the threats remain just as serious and relentless as before. The young male must quickly learn where to hide, where to hunt, and when to disappear from sight. Fortunately, he belongs to one of the most remarkable groups of animals on Earth. Octopuses possess nervous systems so advanced that scientists continue studying their intelligence with fascination and curiosity. A large portion of their neurons are located within their arms rather than entirely inside the brain. This unusual arrangement allows each arm to perform complex actions with an impressive degree of independence. While many animals rely on instinct alone, octopuses often demonstrate learning abilities through direct experience. They can remember successful hunting techniques and adapt their behavior when familiar methods stop working. Researchers have observed octopuses solving puzzles, opening containers, and escaping enclosures designed to hold them securely. Such abilities have earned them a reputation as some of the most intelligent invertebrates ever studied. Their bodies are equally extraordinary and unlike those of most creatures sharing the same environment. Instead of a rigid skeleton, they possess soft, flexible bodies capable of squeezing through surprisingly narrow spaces. This flexibility allows them to reach hidden prey and escape predators that cannot follow them. Yet the same softness also leaves them vulnerable whenever camouflage and speed fail to provide protection. To improve their chances, octopuses evolved one of the most impressive camouflage systems found in nature. Specialized skin cells allow them to rapidly change color, pattern, and even surface texture. Within moments, a visible animal can appear almost identical to a nearby rock, shell, or patch of coral. Predators searching for movement often pass by without realizing their intended target is still present. When camouflage alone is not enough, an octopus may release a cloud of ink into the water. This temporary distraction creates precious seconds that can mean the difference between life and death. Hunting presents another daily challenge because obtaining food requires both patience and precision. Crabs, clams, shrimp, and small fish often hide in places that demand careful investigation. A successful octopus learns how to explore cracks, lift objects, and manipulate prey with remarkable dexterity. Every meal provides energy needed to continue growing and surviving within a competitive ecosystem. However, Every hunting trip also increases the risk of attracting attention from larger predators nearby. Life therefore becomes a constant balance between seeking food and avoiding becoming food. As months pass, the male octopus develops into a capable and highly efficient ocean hunter. He has overcome dangers that killed most members of his original generation long ago. His intelligence, adaptability, and survival skills now place him among the ocean's most fascinating creatures. Yet despite all these achievements, a far stranger challenge waits ahead in the next stage of life. Hidden within his biology is a destiny unlike that of most animals roaming the planet. The very event that fulfills his purpose will eventually become the beginning of his downfall. By the time a male octopus reaches maturity, he has already survived challenges that would overwhelm most marine animals. Each scar, escape, and successful hunt represents evidence of an extraordinary struggle for survival beneath the waves. Yet adulthood does not bring safety, stability, or relief from the dangers that have followed him since birth. Instead, the stakes become even higher as his body begins preparing for its ultimate biological mission. Before reaching that moment, he must continue navigating an environment filled with constant uncertainty and risk. Sharks patrol the waters searching for vulnerable prey, while larger fish remain alert for sudden opportunities. Dolphins, despite their intelligence and playful reputation, can also become highly effective octopus hunters. Even hidden dens are not always secure because many predators specialize in locating concealed animals. To survive, the octopus relies on a combination of stealth, flexibility, and rapid decision-making. Scientists have documented countless examples showing how octopuses assess situations and alter their behavior accordingly. When threatened, they may flatten their bodies, mimic surrounding objects, or retreat into narrow crevices. These responses reveal an animal constantly gathering information and making survival-based calculations. Such intelligence is especially valuable because the ocean rarely offers second chances after a mistake. Every encounter with a predator becomes a test of perception, timing, and adaptability. Meanwhile, finding food remains an endless responsibility that cannot be ignored for long. Hunting demands energy, but obtaining that energy often requires exposing oneself to danger. Crabs may defend themselves with powerful claws, while fish can disappear before an attack is completed. Failed hunts waste valuable resources and increase the pressure to find another opportunity quickly. The ocean itself adds further complications through changing currents, storms, and shifting habitats. A shelter considered safe one day may become exposed or destroyed the next. Environmental disruptions can force octopuses to abandon familiar territories and search for new refuges. Human activity has made these challenges even more severe across many marine ecosystems. Pollution introduces harmful materials into habitats where octopuses hunt, hide, and reproduce. Plastic waste can alter environments and create hazards that did not exist in natural conditions. Overfishing affects food availability and changes the balance of entire underwater communities. Habitat destruction removes important shelters that octopuses depend upon throughout their lives. Despite all these obstacles, some males successfully reach the stage where reproduction becomes possible. From an evolutionary perspective, this achievement represents the primary objective of their existence. However, researchers noticed something unusual when studying mature male octopuses after mating. Instead of continuing life normally, many individuals began showing signs of physical decline. Their behavior often changed in ways that appeared strange and difficult to explain. Some reduced feeding activity even when food remained available nearby. Others displayed decreasing coordination and reduced interest in normal daily activities. These observations suggested that something significant was occurring inside the body after reproduction. At first glance, the decline seemed almost contradictory to the goal of survival. Why would an animal fight so hard to reach adulthood only to deteriorate afterward? The answer did not appear to involve injury, starvation, or ordinary aging alone. Evidence increasingly pointed toward internal biological mechanisms activated during the reproductive process. Hidden deep within the octopus was a system that appeared to transform success into self-destructs. Understanding that system would eventually reveal one of the strangest reproductive stories in the animal kingdom. The mystery of why male octopuses die after reproduction has fascinated biologists for decades. At first, some observers assumed the animals simply exhausted themselves after completing an energetically demanding mating process. Reproduction certainly requires effort, but this explanation alone failed to account for the dramatic physical decline that followed. Scientists therefore began searching for deeper biological causes hidden within the octopus body. Their investigations eventually focused on a small but extremely important organ known as the optic gland. Despite its name, this gland is not primarily responsible for vision or processing visual information. Instead, it functions in ways somewhat similar to hormone-producing structures found in vertebrate animals. Researchers discovered that the optic gland undergoes significant changes when reproduction begins. These changes trigger powerful chemical signals that influence behavior, metabolism, and overall body condition. In mature males, the reproductive drive becomes one of the strongest priorities governing daily activities. Finding a female becomes more important than continued growth or long-term survival. Once a suitable mate is located, the male uses a specialized arm called a hectocotylus. This modified arm transfers packets of sperm into the female's body during mating. The process itself may appear simple, but its biological consequences are profound. After reproduction, internal hormonal activity begins shifting in remarkable and destructive ways. Many males gradually reduce their food intake and become less interested in hunting. As feeding declines, the body receives fewer resources needed for maintenance and repair. Physical condition slowly deteriorates while overall strength begins fading. Coordination may worsen, and responses to environmental threats often become less effective. The animal that once excelled at survival starts losing the abilities that kept it alive. Studies suggest that these changes are not accidental side effects of reproduction. Instead, they appear to be part of a programmed biological sequence shaped by evolution. One leading explanation argues that post-reproductive death benefits the next generation indirectly. By dying, the male no longer competes with younger octopuses for food and shelter. This may increase the chances that future offspring can access essential resources. Another possibility involves energy allocation during the reproductive stage of life. Evolution may favor investing everything into successful reproduction rather than maintaining the body afterward. Under this strategy, survival beyond mating provides relatively little evolutionary advantage. Evidence supporting this view comes from the predictable nature of the decline across many octopus species. The